Okay, this is Math 105, Section 1.3, Part A. We're going to start by talking about algebraic expressions. So first we're going to talk about a variable. Okay, so a variable is a letter that can represent any number from a given set of numbers. So generally, if we don't specify, we assume the real numbers. Okay, so we generally start with x, y, and z, and to represent numbers, we use those variables. And other letters as well. Okay, and an algebraic expression involves those variables in some capacity. So this says 2 times x squared plus 3 times x plus 4. Here we're taking the square root of x plus 10. Here we're using the variables y and z, but we're taking y minus 2z over y squared plus 4. Okay. Notice that there's no equal sign in these. These are not equations; they're called expressions, which means we're not solving anything. We're just looking at an expression involving variables and numbers. Okay. So a monomial is an expression of the form a times x to the k, where a is a real number and k is a non-negative integer. So think of like this is a monomial here, 2x squared. This is another monomial, 3x, and this is another monomial. So we call those terms. So this thing has 3 terms because it has pluses in between each term. Okay, a binomial is 2 monomials, so it has 2 terms. A trinomial is 3 monomials or 3 terms. Okay. So when we talk about anything with some terms in it, we call it a polynomial. So it could have 1 term, could have 2 terms, could have more than that. Okay. So we say a polynomial is an expression of the form a sub n x to the n plus a sub n minus 1 x to the n plus 1, etc., plus a1x plus a0. Now these a's are real numbers, and we call those our coefficients. So if we go back to the other one, we had, let's say we had 3x squared, our a would be 3, okay, and our n would be 2. Okay. Now the n on the subscript on the coefficients on the number part just corresponds to the exponent. So let's say this was x cubed. This would be a3, whatever that number is. Okay. And then the degree of the polynomial is the highest power of x that you see in this expression. So whatever the highest power of x is. Now these n's are always going to be positive integers. Okay. So we're not going to have negatives here, and we're not going to have fractions or decimals. We're just going to have like 3, 2, 1. We usually do that in descending order, so this will be the highest power here, when we put them in that order. And then this one is just a number, a0. Okay, this would be like 2x or something like that. Okay, so here's some examples. This is called a trinomial because it has 3 terms, 1, 2, 3. Okay, the terms are 2x squared minus 3x and 4, and the degree there is 2. That's the highest power of x there. Now notice I put minus 3x for one of the terms. So when if there's a negative in front, count that as part of your term. Okay, this is a binomial. It has 2 terms and has a degree of 8. Okay, so my terms are x to the 8 and 5x, x to the 8th and 5x. This has 4 terms. This isn't in the proper order, but we have 4 terms: 3 minus x, x squared, and minus 1/2 x cubed. Okay. And then our degree is 3. That's the highest power of x there. Here's a binomial again, two terms, 5x and 1. And then our highest power of x is just 1, so our degree is 1 there. Okay. This is a monomial, 9x to the 5th. We only have 1 term, and our degree is 5. Okay. Here's a monomial that's just a number. Now we also consider that a polynomial, but it just has 1 term of 6. Our degree is 0 because we don't have an x to the 1. Actually, we have an x to the 0 there. Okay, when we add and subtract polynomials, generally we're using our properties of real numbers. So we're going to combine like terms, and that would be terms with the same variables raised to the same power. Okay, so we're going to use our distributive property there. Okay, so for example, we have an x to the 7th 5 times, and here we have an x to the 7th 3 times. That number in front, the coefficient, tells you how many of those x to the 7ths you have. So we have 5 of these x to the 7ths, and then we have 3 more of these x to the 7ths. So basically we're just adding the 5 and the 3 to get 8 x to the 7th. So like terms have the exact same variable configuration with the same exponents, exact same exponents. So this says 5 of these, and this says 3 of these, and you add them up and you get 8 of those. Be careful if you have a negative in front of parentheses. That changes the sign of both things inside the parentheses. So negative b plus c will be negative b minus c. Okay. Basically, we're doing distributive property where our a is -1. So when you see that negative in front, it's like you're multiplying -1 times whatever's inside the parentheses, and that changes the sign of everything inside there. Okay, so here's an example where we're adding, subtracting polynomials. So we're taking the sum of this one, x cubed minus 6x squared plus 2x plus 4, plus x cubed plus 5x squared minus 7x. So we can combine our like terms here, okay? So we have 2x cubes there. Okay, so we have 2x cubes. Here's where we're doing the sum. And then we can put these as like terms, a minus 6x squared plus 5x squared. And then these are like terms as well, this 2x minus 7x, and then we don't have a like term with the 4, so we can just put that at the end. So we're grouping the like terms. Now that's our associative property that allows us to do that, because we're really adding a bunch of terms. You know, some have negatives in front. Okay, and then we do that, we get 2x cubes, we get minus 1 x squares, we get minus 5 x's, and just the plus 4. So that's how we find the sum of two polynomials. Okay, we're subtracting two polynomials. So remember, that's like multiplying -1 times that second one. So we're going to get x cubed, and that's going to be minus x cubed here, minus 6x squared, and then minus 5x squared there, okay, plus 2x plus 4, and then a minus 7x, which gives us a plus 7x. So this minus is going to change the sign of everything in that second polynomial. And then we're combining like terms, so we have an x cubed minus x cubed. Okay, we have a minus 6x squared minus 5x squared. Okay, and then we have 2x plus 7x. So we'll group those together, and then a 4. Okay, the x cubes cancel, so we don't have any of those. We have minus 6 and a minus 5x squared, so that gives us minus 11. And then we have a 2x minus 7x gives us 9x, and then the 4. You don't need to show this grouping term in your work and quizzes or tests or homework. Just it can be helpful if you're doing this for the first time, but it's not necessary. Okay, so when we're multiplying algebraic expressions, we're finding what's called the product of polynomials. Okay, we use the distributive property sometimes repeatedly. Okay, sometimes more than twice. Okay. So for two binomials, maybe binomials means two terms, we're using FOIL. Okay, and we talked about FOIL before, but we'll look at it this way. So we have two terms, a plus b times c plus d, so two binomials, and that means you're going to take the a and multiply it times c plus d, and you're also going to take plus b and multiply it times c plus d. So we're distributing twice here. We're distributing the a and this c plus d and then the b. Okay, and when you do that, you're going to get ac plus ad plus bc plus bd, but there's a shortcut for doing that. Okay, so when it's a binomial times a binomial, we can use FOIL. Okay, which means we're going to do the first terms first in each one, so a times c, then the outside, that's what o is, so a times d. Okay, then the inside terms, which are these ones, b times c, and then the last ones, which is b times d. So we get the same four terms when we do that. But there's kind of a shortcut way to do it, a way to remember that. That only works when you have a binomial times a binomial, FOIL. Okay, here we're multiplying a trinomial and a binomial, so we can't use FOIL here. But we're going to take the 2x times all three of these terms, so 2x times x squared minus 5x plus 4, plus 3 times x squared minus 5x plus 4. So we're using the distributive property on both of these. Okay. And that will give you 2x times x squared minus 2x times 5x plus 2x times 4. And then we're multiplying the 3, so 3 times x squared minus 3 times 5x, because there's a minus here, and then 3 times 4. Okay, so that gives us 2x cubed minus 10x squared plus 8x, and then 3x squared minus 15x plus 12. And then we combine like terms, we'll get 2x cubed minus 7x squared minus 7x plus 12. So that would be our final answer there. Another way to do this is to use table form. So what we're doing is kind of like the way we do long multiplication. So we would take 3 times x squared, 3 times minus 5x, and 3 times 4, thinking this is like sort of like our ones place, and this is like our tens place. Okay, so that gives us 3x squared minus 15x plus 12. And then for the 2x, we'll do the same thing, but we're going to move the place values over so they line up with like terms. Okay, so we're going to do 2x times x cubed, or we could start with this one, 2x times 4 gives us 8x, but we're going to put it under the x terms. And then 2x times minus 5x is minus 10x squared, and we'll put it under the x squared terms. And then 2x times x squared is like 2x cubed. And everything's lined up, so we can just combine like terms by adding vertically. Okay, so 2x cubed minus 7x squared minus 7x plus 12. This is kind of maybe an easier way to do this, so it's easier to kind of keep things in order. Either way is fine. Okay, so here's some of our special product formulas. If you take a plus b times a minus b and FOIL that, you get a squared minus b squared. Basically, your outside-inside terms cancel, so minus ab is outside and plus ab is inside. We call this a difference of squares. Okay, so a plus b times a minus b is a squared minus b squared. Okay. If you square something like a plus b, now remember it's not a squared plus b squared. We can't just distribute the square there. We actually have to FOIL that, and we're going to get a squared plus 2ab plus b squared. So we get two ab's in the middle. Okay. When we have a minus b squared, we have minus 2ab in the middle. So we get minus ab twice in the middle. So again, we can't just say a squared minus b squared there. Okay, that's what this is. That's a minus b times a plus b. Okay, an a plus b cubed. Now we can't say it's a cubed plus b cubed, right? We've got all these middle terms too. We have to multiply a plus b out 3 times. Okay, and the same with a minus b cubed. We have to multiply a minus b. Okay, so here we're just substituting from one of the formulas from before. This is like an a plus b squared formula, but when you have something like this, you have to say x squared plus y cubed times x squared plus y cubed. And when you do that, you're going to get x squared squared, okay, plus 2 times ab, which is x squared times y cubed. Okay, so there's 2 ab's, and then plus y cubed squared. So remember, you can't just do x squared squared plus y cubed squared. That would be these two, but don't forget the middle part. There's my 2ab there. Okay, so here's some examples using our special product formulas. So let's look at 3x plus 5 quantity squared first. So this is a plus b squared. So this is a, it would be 3x squared, plus 2 times ab plus 2 times 3x times 5, okay, plus b squared, which is 5 squared. Okay. Remember, when you're squaring this, you have to square the 3 and the x. So that would give us 9x squared. 2 times 3x times 5 is 2 times 3 is 6 times 5 is 30x. Okay. And then 5 times 5 is 25. Okay. For b, we have x squared minus 2 cubed. So we're going to follow our formula there, but we have basically x squared minus 2 cubed is x squared cubed minus 3 times a squared, so x squared squared, times b plus 3 times a times b squared minus b cubed. So that's the last one. And then we do all this multiplication. X squared cubed is x to the 6th. 3x squared squared times 2 is 6x to the 4th. 3x squared times 2 squared is 2 times 2 squared is 4 times 3 is 12, so that's 12x squared, and then minus 2 cubed is minus 8. So we're following the formulas from before, but you also do this by multiplying x squared minus 2 times x squared minus 2 times x squared minus 2, doing distributive law a bunch of times, because you're multiplying 3 times there. Okay, the last thing we'll look at for the first part of the section is factoring out common factors. So we use, when we expand algebraic expressions, okay, we use what's called the distributive property, right? But sometimes we want to do the opposite. We want to reverse this process, okay, by what we call factoring, okay, which means we're taking an expression and we're writing out into parts that are multiplied. Okay, like we're breaking it down into components. So for example, let's say I wanted to factor the number 12. I could say 12 equals, now I know 2 goes into 12, right? And then it goes into 12 again, and then 3. So 2 times 2 times 3. So when I factor 12, I'm going to break it into 3 parts that are multiplied. These dots mean multiplication. 2 times 2 times 3. We call these prime numbers because we can't factor them anymore. So these are, we're finding the prime factors of 12, and we say, okay, 12 is 2 times 2 times 3. So we're not simplifying, we're factoring, we're breaking into parts that are multiplied. Okay. So, for example, if we're factoring x squared minus 4, we can factor that into x minus 2 and x plus 2 as our factors. Now we call that a difference of squares. So x squared minus 2 squared, and we saw that from one of our formulas from before, is x minus 2 times x plus 2. So that's how we factor that. And we can't factor these anymore, so we would say that's completely factored. Okay, so let's say we want to factor this polynomial here. 8x to the 4th y squared plus 6x cubed y cubed minus 2xy to the 4th. The first thing we do is look for a common factor in all these terms. In fact, we want to look for the greatest common factor. So a way to do that is to look at the coefficients, the number parts first, and find the greatest common factor of all those, and that is 2. 2 goes into all those, 8, 6, and minus 2, right? And then look at our variables, and if you see an x in every term, pick the smallest exponent. Okay, so x to the 1 is going to go into all these because x goes into x to the 4th, and it goes into x cubed, and it goes into x. Okay, and then for these three terms, we have y squared, y cubed, y to the 4th. So the smallest exponent there is 2 on the y. So y squared would go into here, it would go into y cubed, and it would go into y to the 4th. So this is what we call our greatest common factor for these three terms, okay, for this polynomial. So what we're going to do is divide that 2xy squared out of here, okay, and we do that, we get 4x cubed. We're going to divide it out of here, and when we do that, we get 3x squared y. Okay. And we're going to divide out here, and we divide that out here, we get minus y squared. So basically we can factor out this greatest common factor, and these are the three terms we have left over when we divide them out. So we have 2xy squared times 4x cubed plus 3x squared y minus y squared. And then we could just leave this, we don't have any common factors in here anymore, and we can't really factor that trinomial anymore. Okay, and on this one, we have 2x plus 4 times x minus 3 minus 5 times x minus 3. Now these are already partially factored, but it's not completely factored because we have this minus in between. But notice we have a common factor here of x minus 3. Okay. All right. So we can say, okay, let's divide the x minus 3 out of this term and this term. When we do that, we get 2x plus 4 minus 5. And we have brackets because we're multiplying the x minus 3 times both of these. Okay. And then we can just combine these like terms. We have 4 minus 5, so we get 2x minus 1 times that x minus 3.